Welcome guys, I'm Gio here, and in this video we continue exploration of reduce function. Let's jump into our code, and this is what we have accomplished in the previous video. These are some list operations. If you haven't checked previous video, please do now, because we kind of build up on top of that to really understand what reduce is. So here we have different list operations, list functions. They do different things, but they have certain things in common, of course. So right now, we're going to think about those functions and try to extract some common characteristics, and then maybe we can implement the reduce function ourselves. That way we can get a better understanding of what reduce is exactly. So if we look at those functions, one common thing that they have certainly is that they operate on lists, on arrays. So we can, let's list them down. Let's list these common things there. So the first thing is that they operate on lists, So they use the list to, to derive the results. Now another thing, if we look at this closely, is that they have some initial state of final result, that should be returned. So in this case, we transform it into some object. Here we get some string. In this case, initially we have an empty array. So another common thing is that they have some initial state that they operate on. So let's look at this. Initial state, they have initial state. Now let's look at this again, and another thing we might notice is that they operate on all elements of given list. They iterate over the list, to produce final result. So in all of these cases, we go through all the elements of our list and we perform some operations on them. So another common thing is that they iterate over the list. Now let's look at this, these for loops closely. And when these functions iterate over the list, they perform some operations, and they kind of update this initial state to derive the final solution. So in these for loops, these bodies here are certain operations, and we don't know exactly what they are, but we can certainly say that within this loop, these functions can perform, a certain operations, and they have this in common. So we can say that they have a certain operation. It's not obvious what is common between these, between these bodies, but we have to think about this. We can certainly say that for every item in the list we have a certain operation, but what is common with these operations? And one of the things is that they kind of modify this initial state here. They in these for loops here, we have some certain logic that contribute to final solution. In this case, we are pushing the items into the array. Here we concatenate strings. In this case, we are adding the items into our initial empty object, and so on. So these operations here that are performed for every item in the list kind of, use this initial state. So we can say that operation uses initial state for every item in loop. So this is another common characteristic of these functions. And by the way, we can have many different examples like that, and we can find that these characteristics are very common. So now let's think about this. Can we somehow abstract these things away, and if we can abstract certain things away, then let's see if we can define a better function, and then we can re-express those things, those functions in this with this abstraction, with this new function. So now let's start writing a new function, based on our observations, and let's call it reduce. Let's call it reduce. And what this function is going to receive, certainly if we look at this, it's going to receive a list. Well, because it's a list operation, and we're going to operate on this list, and it's obvious, right? Another thing is that we need the initial state, and this might differ. We don't know exactly what this initial state might be, so we should let the user decide what it should be. So let's call this state. So for sure, we can say that we should iterate over the list, and this will be a function, and in this function we're gonna give this function the current item, and current item is list I. But besides the current item here, we certainly want to pass in some state, this state function, because if we look at this closely, this operation always operates on a given item, current item that we are iterating over in the list. And in this case, this is the item here, list I. And also these operations work on our state, our initial state, our state that should be returned in the end. So here we pass in the state, and also we pass in the given item, given current item. So now this function, should return to us a new state. So here we can say that we update our state with this action, and in the end we will return this. We will return the state. So now let's look at this closely. So we iterate over, so we have defined our reduce in terms of 3 parameters. First one is a list, and this is a list that we operate on. We iterate over this list. The second item is our initial state that should be extended, and this initial state represents this initial state for our final solution. And here we also receive this from the user because we don't know exactly what is going to be. And also we receive our action function, and this action function will operate on our current state in our solution and our current item in the list. So, and in the end, this function should return the new state. And once we receive this new state, we perform the same thing for all the items. And in the end, we will receive the result. Now, it might seem a bit complex now, but let's look at those functions. So let me comment this. Now let's look at this. Okay, let's comment out this as well. And let's look at this, two object function here. So now let's try to redefine this in terms of reduce. So let's write this to object. And here, of course, we're going to receive the list, but instead of writing this body here, this complex body, let's try to use reduce function. So let's write reduce, and in the reduce, we pass in our list, then we pass in our initial state, and since we know that the final result of this should be an object, we initially pass an empty object. And now it's the most interesting thing. It's an action function. So what we do here in our action function, first we take whatever is in the state, so we have to create our new state. This new state consists of the old state, which is a regular object, and we use the spread operator here. And we also want to add the new item inside our object. So for this, we can go there and add the first item from our tuple, from our pair, as the key. This is special syntax, and the second item as the value. Now let's comment this out and test our new toObject function. And as you see, it works fine. We received this transformed object. We took the list and got the object from it. Now let's comment this out and try another list. And again, we have received the result. So now let's look at these two functions closely. Even though the first one might look a bit trickier, is more cleaner than that. Once you understand what reduce is, you look at this and you instantly know, okay, I know what's going on. You have to just look at the list and then initial state, the action function, then in the end you will know what it's going to do. Well, in this case, you have to carefully look at this, this thing here, this initial state. It might have different name. Then you have to track this loop and look at these expressions, and it's really hard to think about this, and to analyze. But once you know the reduce and what this function is doing, you can look at this and say, oh yeah, of course I understand what's going on. And we can certainly do better. Let's go back to our reduce function and redefine it. We can use carry function from Ramda. I have included this library. And with this function, let's redefine our reduce function, and let's pass in the action function first. Or let's pass in the state first, then action function, and finally let's pass in the list. Now we can redefine this toObject function in a more clean way, in a cleaner way. So here, if we look at this, we can remove this list here. We can rearrange things here. We can completely remove this. And just by writing this expression, we can redefine our toObject function. So because this function is carried, we supply our state and action function only. And the last argument will be expected when we execute this toObject function with some list. Now let's test this again with the list. And of course it is working. Let's test again with this list. And yes, it's working as well. So now if we look at this, it looks even cleaner, even though we have some syntax highlight errors. It's working fine. So we have taken this thing here, this complex thing that is not very easy to read, and we have turned it into something that is very readable. And once someone understands this reduce, it's a very common thing. She will look at this code and instantly understand, oh yeah, I see what's going on. We have this initial state, and then we have this transforming function. And all you have to do is look at this transforming function, and you instantly know what you're going to achieve. While in this case, it's not really clear. So let's turn our attention to other functions and try to redefine them in terms of new reduce function. Here again, we have, let's start writing this. We have a toString function, and here we receive list and separator. So we just take, our item and just add it to our state plus item. And in the end, we will return a new state. And also we have to consider this separator here. But how do we know that, we have a special condition here, but how do we know that this is the last element? Well, it's very easy. We can add another flag here, another option here into our action function, and pass in Boolean flag that indicates if the element is last, we can indicate this. So we can write this down. If I is equal to list length -1, then this is the last element. So we can supply this to our action function. And in the cases we don't want to use it, we can ignore this completely. And in this case, let's look at this. And here we can get this flag is last. And if the item is last, or it is not last in our case, we will just add separator as well. So now, finally, we can pass in the list. So let's look at this. Let's comment this out and test it with new toString function. Oh, sorry, my mistake here. Instead of res, we need the state. Let's run this again. And we have got this weird string here because we haven't supplied the separator. Let's specify an empty string here. And yes, we've got the result. Let's pass in another list and specify space as a separator. And it is working fine. As you see, if we compare these two results here, it looks much more cleaner to me. And again, once you're familiar with reduce and you've used it, when you encounter this in your code or into other code, you will just understand what's going on here. So we can comment this and turn our attention to the last function. And it's an interesting one. It's called long strings. And let's redefine this with our reduce function. So here again, we will have this same signature. Here we have list, character number, and let's define this function. So initially, we have this empty array, empty list, and now we can define our state, our action function. We have the state, we have item. We are not using if the element is last or not, so we can ignore the last parameter here. And now let's define this. So here we have to make a check, if the length of current item is more than character number, then we want to add this element into our final solution. So here we will return new array where we have this item. But if that's not the case and this is not a long string, it is not considered as a long string, then we just return the state, whatever state was before. So we don't modify this. Now let's comment this out and let's test some list here. And let's run this. Oh, sorry, I have forgotten to pass the list here. So we pass in the initial state or transforming function and the list that we want to operate on. And here we got no result because of my mistake. I have misspelled the length. And as you see, it's working fine. Let's type in 1. And we've got off. Let's type in 3. And yeah, it's working. It is filtering the strings. And again, for me, that looks much cleaner. We are not using this for loop. And we just pass in the things that we want to, operate on the list. So now, let's look at the reduce again and think about this. So reduce is a list operation. We provide it with our initial state, our action function that we operate on for every item, and the list that we want to operate on. Then this reduce function will generate our final state, our final solution with given params. If you think about this, map and filter functions are specialized cases of reduce. But this one can be used to define the map, to define filter, and to define all sorts of list operations that you want to have. And this is a very, very powerful function. And as you see, it kind of removes a certain things that when you're transforming one list into another list or into something else. And we of course can use reduce function from Ramda. Reduce, and it's already carried, and you can check its documentation. It's very easy to use. You don't have to write this yourself. And that's it for reduce. So to recap this, it's a list operation. We provide our initial state, we provide our operation and the list that we want to operate on, and then it derives the final state, final solution by iterating over the list and performing our action function. So that's it for reduce and for this video. If you enjoyed it, click the like button, subscribe, and share it with your friends.